Okay, so this is the convex lens tracing, and we're going to start this off by making my normal. I tried my best to make this 90 degrees, but I might not have done a very good job, and it doesn't look like I did. Crap. So, if you look here, it looks like it's not a 90-degree angle coming into the actual lens. So I'll measure that, because that's going to be theta 1. So I got something like 2.3 degrees. 2.3 degrees. Then I'm gonna, let's see here. So now I got to be very careful. If this is my normal, so this is on top of it, the refracted one's going to be below it. So I'm going to run that through Snell's law. N1 sine theta 1 equals N2 sine theta 2. So it's coming from air into the block. So sine 2.3 divided by 1.49. So I get 1.5 degrees. So then I got to come over here and go 1.5 degrees. Like that. Okay, so boy. Can I assume these are parallel? I don't know if I should assume they're parallel. They probably will be if I traced them well enough. Yeah, they look like it. So I'm going to go 1.5 degrees below this one. Alright, now my next order of business is actually finding the center of curvature. So what I'm going to do is pick 3 points. I'll pick them here. Remember, pick them far away. That gives you a good chance. So what I'm going to do is then find the perpendicular bisector on these two segments. So now, remember, to find the perpendicular bisector, we take a compass, open it up pretty wide, put it stick the point in here, make my arc. Come on. Oh boy, I may have to make it smaller. Make an arc, make an arc, pointy end up this side, make my arc, make my arc. So these two guys cross right here, right there. Now I'll do the same thing. Looks like my center is somewhere right here. So I got my center to be right there. Now, what do we even do? What's that for? Why do we even find the center? Well, the reason that we find the center is so we can get the normal right here, because this is our ray. So right here, this is the normal. It's my ray. I can take this guy out now. I don't need it. This was just the segment that I used to find the bisector. And then I'll find my normal right there. And I'll label them as such. Those are my two normals. So now this will be theta 1, just as this will be theta 1. So I'll measure those angles. Looks like 21.0 degrees. And then it's like 19.5. 19.5 and 21 degrees. So I'm going to run both of those through Snell's law. So it's coming from the glass, 21 into air. So that's the first one. .3, and in the second one, run that one through Snell's law, 1.49 sine theta 19.5. It goes into air. 0.49 sine 19.5. 29.8. So again, so you see how this one, one's on top of the normal, then this one has to be on the bottom of the normal. That's the biggest mistake people make. So I got to do it 32.3 degrees. So I stick this in here. 32.3. So it's something like this. And my other one, okay. Again, now be careful of your normal. See, this one's on the bottom of the normal, so this one has to be in the top of the normal. And I got to do that at 29.8. So 29, that's almost 30. So I get my rays looking like this. I can extend them. I don't know if they're going to meet on this page. So it looks like they're meeting off they meet off the paper, but let's go get my thing and see if they actually work. Well, I can't check it. My friend Jake took it, so shoot.